In this lesson, you're going to learn how to do polynomial long division. Let's begin by looking at something that you already know. Dividing polynomials by monomials. So 3 is a monomial. So if I divide this by 3, it means that I'm dividing each term above by 3. So 3 divided by 3 would just be 1x squared. 48 divided by 3 would be 16x, and negative 9 divided by 3 would be negative 3. So it would result in that trinomial. Next, you're told to divide 4x to the 4th y cubed by negative 2xy. So I'm going to begin by dividing my coefficients. So 4 divided by negative 2 would be negative 2. Next, my x's have like bases, so x to the 4th divided by x would be x to the 3rd, because the rule is you keep your base and you take your top exponent minus your bottom exponent. And then finally, y cubed divided by y would be y to the 2nd. Again, keep your base and subtract your exponents. But in this lesson, we're really going to focus on, well, what do we do if we're trying to divide a polynomial by something bigger, such as a binomial or trinomial or any type of polynomial? And in order to do this, we need to revisit something from elementary school. We're going to go back to long division. So I'm going to remind you of the algorithm for this. So I begin by setting up, I take my divisor, put it outside the division house, and the dividend beneath. And you begin by asking yourself, does 13 go into 4? No. Does 13 go into 48? Yes. How many times? Well, 13 times 3 is 39, times 4 is 52, so I'm going to say that it goes in 3 times, and I write that directly above the 8. Then I multiply. 39. Then I subtract. 48 minus 39 is 9. Next, I bring down the next digit, and I repeat the following steps, or the previous steps, I should say. I now ask myself, how many times does 13 go into 93? And it goes in 7 times. 13 times 7 is 91, and I'm going to subtract. When I do, I get 2, and I again bring down the next digit. Now ask myself, how many times does 13 go into 21? And it's just going to go in 1 time evenly. So 1 times 13 is 13, subtract, and I get 8. Now, one of the ways to write our quotient now would be 371, and I'm out of values to bring down, so there's 8 left over. Well, this would be and 8/13. Okay, so 371 and 8/13. You eventually would add decimal points and continue the long division using it in decimal form, but this would be an exact answer in fraction form. We're now going to apply this algorithm to polynomials. As you set up your polynomial long division, you want to make sure that in this polynomial we're dividing by a trinomial, you want to make sure that there are no missing terms. If there are, we're going to put zeros as placeholders, but my terms go quartic, cubic, and it looks like I'm missing a quadratic. So as I set this up, I'm going to do 3x to the 4th minus 5x cubed plus 0x squared plus 4x minus 6. And I'm dividing by a trinomial. I also want to make sure that there's nothing missing as far as terms, but it goes quadratic, linear, constant, so it's in good shape here. So as you begin your long division, you want to just look at the terms with the highest powers. So I have a 3x to the 4th divided by x squared. So off on the side, I'm just going to divide those two powers because I'm asking myself, how many times does x squared go into 3x to the 4th? Well, that would be 3, keep my base, subtract my exponents. It would go in 3x squared times. So I'm going to take this 3x squared and put it above the term that it matches in this trinomial. Okay, these degrees line up. Now what I'm going to do is take this 3x squared here and multiply it by this trinomial. So I'm going to make 3 multiplications, and I'm going to write that directly beneath this. So 3x squared times x squared would be 3x to the 4th. 3x squared times negative 3x would be negative 9x cubed. And then 3x squared times positive 5 would be positive 15x squared. Now I'm at the subtraction part of the long division. So here's what I do. Put a subtraction sign out front, but then I remember, you know, when I'm subtracting, that's really like distributing a negative to the second polynomial. So what I'm going to do is change the signs on absolutely everything in this bottom row, and now just add. So this is eliminated. Negative 5x cubed plus 9x cubed is positive 4x cubed. 0x squared minus 15x squared is negative 15x squared. Now I bring down the next term, the plus 4x, and I'm back to the beginning. I'm going to repeat the process where I look at my leading term here, and I'm seeing how many times just x squared goes into 4x cubed. So until you get good, I highly suggest off on the side, you divide them. So 4x cubed divided by x squared would be 4x. That tells me it goes in positive 4x times, so I put plus 4x directly above this term here. See how they're linear and they line up. Now I'm back to multiplying. I'm going to take positive 4x times this trinomial, the divisor. So 4x times x squared is 4x to the 3rd. 4x times minus 3x is negative 12x squared. And 4x times 5 is positive 20x. So I'm going to draw my line, and I'm at my subtraction part. But subtracting is like distributing a negative. So I'm going to make this a plus, this a negative, this a plus, and this one here is a negative. So I'm just changing my signs. So and now it's addition. This is eliminated. Negative 15x squared plus 12x squared is negative 3x squared. 4x minus, and I just realized I dropped my x from before, minus 20x would be negative 16x. I then bring down my final term, my negative 6th. One more algorithm I need to do. How many times does x squared, my leading term, go into this leading term? So again, off on the side, I'm going to do negative 3x squared divided by x squared. When I do that, I get just negative 3. So it goes in negative 3 times. What is, from distributing rather, I would do negative 3 times this trinomial, which would give me negative 3x squared plus 9x minus 15. Draw my line, back to subtracting. Well, that means I'm going to be distributing, so change it to addition, and then every sign changes. All right, now I'm adding. These are eliminated. Negative 16x minus 9x would be negative 25x plus 9. Okay, I have no more terms to bring down, so this is my remainder. This is what's left over. So I'm going to write my quotient now in fractional form. So this was equal to 3x squared plus 4x minus 3 plus my remainder of negative 25x plus 9 over the divisor, which was x squared minus 3x plus 5. Okay, so this is definitely can be a tedious process where you make one small error and things are really going to be mixed up. So just some tips would be use nice, neat handwriting and do your division off on the side like I suggested to help you keep things aligned. All right, let's do another practice problem. This one's a little simpler. We're only going to be dividing by a binomial of x minus 2. And I'm checking my dividend and making sure that there's no missing terms. And I see x cubed plus 5x squared minus 7x plus 2. Nothing's missing, so I don't need any zeros as placeholders. All right, so I begin by asking myself, how many times does x go into x cubed? Until I get good at this, off on the side, I'm going to do x cubed divided by x, just dividing my leading terms, which would be an x squared. So it goes in x squared times. Again, I always write my terms by aligning it with what it matches with below. Now I'm going to distribute. I'm taking x squared times this binomial would produce x to the third minus 2x squared. Now I'm at the subtraction part, but subtracting is the same as distributing my negatives, so I'm going to make this a plus, this a minus, and this is a plus. So all my signs changed here in this row, and now it will be addition. So that becomes 7x squared, and I bring down my next term, my minus 7x. Be nice and neat. Back to the beginning now. I'm asking myself, how many times does this x go into 7x squared? So again, I'm going to do that off on the side. 7x squared divided by x is going to be 7x to the first. So x minus 2 will go into it positive 7x times. So I put my plus 7x above my other linear term, and I will now distribute 7x times the binomial, which would give me 7x squared minus 14x. I'm back to the subtraction step, which means I'm distributing a negative sign to this bottom row, and now it's an addition problem. So eliminates, and I get 7x, and I'm going to bring down this final plus 2, back to asking myself, how many times does x go into 7x till you get good? I highly suggest you do it off on the side, and that would go in positive 7 times. So one final distributing, 7 times x minus 2 would be 7x minus 14. I need to subtract, which means I distribute on a negative on the bottom row, and now it's addition. So 7x minus 7x here is 0. 2 plus 14 is 16. So to write my quotient would be x squared plus 7x plus 7 plus a remainder of 16 divided by the divisor. It's your turn now to divide this polynomial by a binomial. Pause the video and then check your answer when you're ready. So I'm going to do this one probably a little quicker than before. So I start by how many times does 2x go into 2x cubed? And that's going to go in x squared times, so I line it up with the other quadratic term, and now I'm going to distribute x squared times the binomial, which would produce 2x to the third plus 3x squared. Now I'm going to distribute my minus sign, so it's an addition problem now, so 2x cubed minus 2x cubed cancels, 7x squared plus negative 3x squared would be positive 4x squared. Neatly bring down the next plus 2x. Back to the beginning, how many times does 2x go into 4x squared? And that goes in 2x times. Back to distributing 2x times this binomial produces 4x squared plus 6x. Back to the subtraction step, which causes me to just change the sign on everything in the bottom row, and now it's addition. This cancels. I get negative 4x. Bring down the plus 9. Final step is how many times does 2x go into negative 4x? That goes in negative 2 times. So I put minus 2, and I'm going to distribute minus 2 times this binomial, which gives me negative 4x minus 6. I'm going to change the signs on everything in the bottom row, and now it's addition, which gives me 15. So my quotient is x squared plus 2x minus 2 plus 15 divided by the divisor of 2x plus 3. Okay, you definitely need to do some practice problems.